on Twitch viewers is twitch.tv/smAshomash. We're now streaming live for today's Cosmology segment here at Smash News Network, least busted name in news. Thanks to our new YouTube subscribers, etc. Please don't forget to press like, share, subscribe, etc. Tell your friends, foes, science noobs, and science pros about the channel. And don't forget to check our playlists as well. There's all kinds of other content besides daily space weather videos. We're also on BitChute. Look for more exclusive content coming there soon. Visit our own website, smAshomash.com, smAshomash.org. We'll redirect you. Today's featured product is available at the smAsho merch link. It is the Do Not Pole Vault the Caldera lightweight hoodie. There you go. Please do not pole vault the caldera. And if you'd like to tell your friends and foes and help support the channel with this handsome and perhaps humorous shirt, since it's so hot that it's cold, we've decided to make today's featured product a hoodie as snow continues to fall all over large portions of the planet. So today's Cosmology segment should be interesting. As if it wasn't interesting, why would I be talking about it? That wouldn't make any sense. First thing we're going to talk about is the Murchison Wide Field Array. Yes, a giant radio array in Australia. An article in it today, about it today, rather, on phys.org. And radio astronomy is super interesting, folks. We use massive telescopes for the realm of radio astronomy. And, well, one of those radio telescopes is going to get even bigger. And we have featured the Murchison Wide Field Array before on the channel. We showed the virtual observatory at the Murchison. It's got some great radio imagery. You can check out their website if you like. Well, guess what? There's going to be an even bigger array, the Square Kilometer Array, which will consist of 130,000 individual antennas spread over 120 kilometers. Again, that article is in the phys.org's Astronomy and Space section. Today's random number generated was 666, the number of the quasar. The number of quasar QSO B1730-130. Here it is on the Pan-STARRS, which is a very high-resolution optical telescope. Here it is on infrared. Note some differences to its infrared. Then its optical. It's today's random object. And number 666 is quasar B1730-130 at the Neil Gorell Swift Bat X-ray Observatory. There are the X-ray outputs from that quasar. And if you want to look up your favorite objects, head to the Neil Gorell Swift Bat X-ray Observatory. For example, if you'd like to look up what's going on with Cygnus X3, just hit find, type in Sig space X-3, and there you go. There's the X-ray transient outbursts from Deneb. Or perhaps you'd like to look up Sagittarius A star. Okay. Type in SGR space A, and there is the core of the Milky Way galaxy and its X-ray emissions. Here's a 16-year chart. Here's a 3-day chart. And here's a 30-day chart of the X-ray output of the galactic core known as Sagittarius A star. Today's astronomy picture of the day is the Sombrero Galaxy. And if you want to look up the daily astronomy picture of the day, head to apod.nasa.gov, apod.nasa.gov, the Sombrero Galaxy. Today's featured edge-on galactic disk, a fantastic view of a likely radio galaxy. And it gives us a great chance to talk about some cosmology. So the fields at the center of this galaxy are likely producing jets, probably in this sort of an orientation. The jets are typically perpendicular to the galactic disk, and this is a very organized galactic disk. And when you view a galaxy edge-on like this, it tends to be a radio galaxy. If you viewed the galaxy from within the galaxy's poloidal fields from this perspective, it would be a quasar or perhaps a blazar. And if you viewed it sort of from this perspective, it would be something like a Seyfert 2 galaxy, an active galactic nucleus. And if you're viewing it from here, it would just be sort of a regular spiral galaxy. As perspective is everything in cosmology. Speaking of perspective, How about the internal mixing of rotating stars inferred from dipole gravity moments? Yes. Well, what's the point? Well, it's a great article today. You'll find it all over the Cosmology wire about stellar seismicity. So this flies right in the face of the concordance stellar evolution model. Let me just reiterate the fact that we've never seen a star born or die, although we've seen stars stop emitting light. We've seen stars restart emitting light. We've seen stars do explosive behavior and do nova events. Ultimately, we do not understand stellar life cycles, and this is yet another chink in the armor of the concordance stellar evolution model. Let me read a quote from this, which I already shared with our patrons. The results published in Nature Astronomy show that the internal mixing is very diverse, with no clear dependence on a star's mass or age. So how it is that stars make heavy elements is definitely something that is under debate right now. Astronomy, cosmology, astrophysics, and indeed geology are being rewritten with some new ideas. It's part of the reason why we have a channel. It's super exciting. And there's the imagery of that, which is not to suggest that the work done by astronomers who are, let's say, misunderstanding stellar evolution is worthless, as that work is not worthless. That work is quite valuable. We just need some tweaks to the models, I would say. And that's today's Cosmology segment. Thanks for tuning in, folks. We'll have to say goodbye to Twitch. We'll bring you back for the meteorology segment.